Welcome. Welcome to this week's Lunch and Learn. We'll get our guests to jump on in a minute, but first of all, I'd like to begin by acknowledging the traditional custodians and owners of the land and those of the land that we are on, the peoples of the Kulin Nation. I also pay my respects to the elders past and present. Each week we discuss a different project and a different material. Today, Ecologics Industry Manager, Doi Lee, welcome Doi, and our guest will be discussing a successful trial on Reservoir Station's shared user path where glass fines were used in the concrete mix. So I'll get Echo and Dev and Philip to reveal themselves. This is a 30-minute session. There'll be about 10 minutes at the end for questions. You're welcome to pop them into the chat or the Q&A during the session. And the sessions are recorded, so you are able to see these recordings after the session. So I'll hand over to Doi and let him get started.
Thank you, Cheryl, and thank you to our panelists for joining today, and thank you to our audience for dialing in. I suppose before we get started, probably a quick round of introductions is in order. I might start with Dev. Did you want to say hello to everyone and introduce your role?
Yeah, definitely. Hi, everyone. My name is Dev. I'm a sustainability advisor at the Northwestern Program Alliance. And Northwest is one of 5 alliances that make up the Level Crossing Removals Program of Works. So I'm here to talk about a trial that was implemented in one of our projects in Reservoir Station. And we worked with University of Melbourne, Philip and Echo over here to get that trial on board. And it's just about using unwashed recycled glass fines in concrete in the shared user path, as you can see in the back over here. It was a very successful trial, so I'm here to talk a bit more about how we got onto the trial, how we did it, the results from the trial, and yeah, share that information forward.
All right, thank you, Dev. And I suppose, so for this trial, it was a Sustainability Victoria funded project looking at recycled glass sand. How did you select recycled glass sand, and is this business as usual or common practice?
Yeah, and a great question. So the reason that we chose recycled glass fines in particular is because it is currently a very readily available waste product in Victoria. So if you think about, so the waste, the glass that we recycle, out of that only 48% actually goes into be made into other recycled products. The remainder of that is actually glass fines. So the tiny, glass fines that over 52% of that is that's what's remaining. And usually because it's hard to be recycled back in, it's usually stockpiled and then sent to landfill because there's really limited use for it. So one of the uses that you can use it for is as a substitute for sand in concrete. Sand, of course, being a virgin material, and also because of the fact that it is mined, it's increasingly becoming mined unsustainably as well. So it's not a very good use of products. So we try and substitute using recycled glass fines. And this has been done before. Recycled glass fines has been put in as sand before, as a replacement of sand before in concrete. But what's very unique about this trial in particular is because we're looking at unwashed recycled glass fines. But previously, the glass fines that we use is always washed when you put it into concrete. Echo and Philip can talk more about why that is, but that's mainly because there's usually a bit of contaminants with glass fines that kind of can limit the way that the concrete chemical composition is made. So we really wanted to explore if there's a way that we can just use the waste product as is in our concrete.
Yeah, absolutely. So Echo, just on that point, can you talk us a little bit more about what's the history behind unwashed glass sand and why hasn't it been used before?
Yeah, I guess as Dave mentioned, the reason is mainly because the contaminants in the unwashed glass fines, which will have negative effects on the concrete performance and also may increase the cost of the mix design. So one of the biggest concerns raised by the concrete industry is the walkability reduction when incorporating the unwashed glass fines as a sand replacement in concrete. The walkability reduction is due to the relatively high amount of clay and silt, as well as some organic impurities in the unwashed glass fines because they're from that waste stream and have been in the stockpiles outside for a long time. So in order not to lose the workability as well as the strength, what we typically do is to increase the dosage of the water reducer, or we call the super plasticizer, in the mix design. But if we do that, it will definitely increase the cost a lot, because the water reducer is very expensive. And I guess that's what the industry doesn't want to see. Also, the possible presence of sugar in the unwashed glass fines is another concern, because the collected waste glass primarily comes from the food containers and also the beverage bottles. So sugar acts as a retarder in the concrete, which will delay the concrete setting. And finally, I think the local government, the Department of the Transportation, is very cautious about introducing the new materials to the current standards, instead of using the well-tried materials. Even though, based on my knowledge, I think some concrete industry are really keen to use new sustainable materials.
Thanks, Eka. So with that in mind, how did Northwest get involved? Like, what was the trial? What were the parameters that you're trying to meet to bring the department on board?
Yeah, definitely. There's a lot to talk about here, because I guess like to do the trial, there's actually a lot of work and a lot of time that went into it to actually pour concrete on ground. I'll give a bit of a background into how we went about approaching University of Melbourne. So initially, back in, I think, 2016, Sustainability Victoria and University of Melbourne had done initial trials, so initial lab testing, to see the feasibility of using unwashed glass fines in concrete. And that trial was actually very successful. We were able to prove in the lab that the concrete met Vicroad standards as it should be met. So because of that, that's when Northwest came in. We were actually met the University of Melbourne in a Sustainability Victoria event, where there was it's like an industry and research development kind of event, where we were presented with different ideas. And this was definitely one that we were very keen on, because we were already able to prove in lab that this was something that's feasible. And we really wanted to be, I guess, one of our projects to have the opportunity to trial this from a lab setting to in real life setting, to see if it's actually feasible in big construction projects as well. So from then, so that's when the initial collaboration formed. So that being us as the industry partner, University of Melbourne researchers and Sustainability Victoria funding us as well. And we also had other players involved, like Hansen, who are the main concreters behind that, made the mix design for us as well. And then finally, Vicroads was also involved in that early stage collaboration. They were interested to see if the results from this can actually go on to inform their standards. So that collaboration of all these different groups kind of started at the, it started at the very beginning when we were thinking of bringing this trial forward. And yeah, that's where it all started. And I guess from when we started that collaboration to when we actually did this trial, the photo that you can see in the background there, it was, I think, 18 months period. So it really did take its time, because we had to make sure that we, implemented the trial really well. So that includes a lot of planning. So working closely, like our engineers working closely with Hansen to make sure the mix design was, perfect. With University of Melbourne working on their testing, with us working on planning and phasing in and what projects we can put it on and things like that. There was a lot of background work that went into it, a lot of workshops and things like that. And so, yeah, that whole process in the end took about 18 months to get implemented in. And so this trial then happened in early 2020 as well. So in Reservoir Station, it was poured in the shared user part. And then samples of this concrete that you can see that's being poured here then was taken by University of Melbourne to do further testing and to do the further, for further research and everything like that. And then the results from that, again, were fortunately it was very positive again, and did show that it met Vicroad standards, and that results and research and papers from that went on to inform the update for Vicroad's section 703. So now, now the update is that we can use up to 10% unwashed glass fines in concrete when you're doing the mixes. So I guess, yeah, so that's the whole story of how this whole trial went on to actually change the standards themselves.
Fantastic. Look, so it sounds like an 18-month journey, and I imagine collaborating across all those stakeholders wasn't easy. So can you tell us, maybe, what were some of the challenges you faced early on, if there's anyone here in the audience that's keen to embark on this journey in future?
So for the early challenges, the challenge that I faced was regarding the experiments at the very early stage of this project. So back then I was replicating a commercial mixed design provided by one of our industry partners, Hansen, but the strength of concrete was not as good as supposed to be. So our immediate thought was that it might be due to the difference between how the concrete is made by us in the university's lab and how it is made by the industry in their concrete plant. So we actually went to Hansen's lab just to see how they make concrete step by step. And then we just tried our best to keep the whole process the same in the university's lab. That's how we minimize those differences and try to get a very good results.
Yeah, right. And so what did that mean for you, Dev, on the project when it came time to actually do this in practice? What challenges or barriers did you face on the project?
I guess one, so me personally, I was more involved during the later stages of the trial itself, but a lot of my colleagues who were part of that initial trial phase, I kind of reached out to them just to get an idea of what their thoughts were about. And what they were saying was one of the initial challenges, I think, and this just comes around the fact that this was a collaboration, a real collaboration between a lot of different types of groups. So, researchers and engineers and concrete people, a lot of different industries coming together. And it's I guess like when you have to deal with people that you don't really usually deal with in day-to-day life, there's differences in opinions and differences in the way that you guys, perspectives and coordination and things like that. So I think there was a little bit of it took some time for us to kind of find that dynamic for us to work very collaboratively together. And of course the fact that we were also together for 18 months, that we did kind of go through that hump really quickly to get that collaboration happening really well to kind of make a really effective trial essentially. So one of the biggest things that really help with that is just communication and having that regular engagement with each other to make sure everyone's aligned with what you need to do. So that was one of the challenges I think that we faced initially. And another thing that I've also been told, speaking to the engineers, is that so initially the design team was a bit more hesitant to get a trial and something like that implemented in the drawings. Of course, if you think about it from the design team's perspective, if you're approaching them with a material that's never been tried before, there's no precedence or there's no quality information, they get a bit hesitant to be like, oh, do we want to specify these things in our drawings? So that was a bit of a challenge for us from a sustainability point of view to kind of get that into the drawings in the end. And to be honest, the main thing that really helped with that is the fact that it was classified as a trial. So that kind of gave us the design team that flexibility and that kind of reassurance that, if anything happens and if this needs to be redone again, it's a trial. We're just trying something new and that's fine. And the trial was in a smaller space because, we're just testing the material at this stage. Fortunately, everything was fine in the end, all is good. But that was one of the things that that really helped us to get it over the line with the design team.
Fantastic. So I think you've answered half of what I was leading to next. So there's a few key lessons learned there from getting into the design, collaborating, but any other key lessons learned or takeaways from this trial you can share?
Yeah. I think definitely want to kind of re-emphasize what I wanted to say earlier, being that communication and communication really was key for the success of this trial. So kind of having that regular engagement is very important. If anyone's thinking of, organizing a trial or anything like that, that engagement is really important to make sure everyone is aligned with what you want to do. And I think that's one of the reasons that this trial was actually quite successful in the end, because we were really able to work together to, get a positive initiative put forward in a project. And another thing that I can think of that maybe might be a bit more unique to our projects, but that really did help us a bit, is the fact that the Alliance model for LXRP is essentially a rolling program of works. So we kind of continually have projects that we are doing as we're going along. And that kind of gave us a lot of flexibility. So inevitably, when you're doing projects and things, initiatives like this, there are hiccups and things that come along that could delay trials and things like that here and there. But because we kind of had that rolling program of works and that flexibility to kind of fit in the trial wherever we can for University of Melbourne, that kind of helped to get the trial implemented when we can. So I think those were two things that really kind of helped us, and in terms of lessons learned, that I think we should, that were really good for the trial.
Right. So would you encourage the continued use of this material as a sand replacement?
Yeah. So speaking to the engineers, the delivery team that did this, they really wanted to get that message out that yes, they were interested and definitely keen on using this material again. And in terms of workability, what they were saying to me was it was just like any other concrete. There was nothing special that you had to do to get this concrete in the ground. It's just that the mix was different, but other than that, they were saying it was like any other thing, any other concrete mix that you would have. So because of that, they was happy to have it again and use it again. Particularly for High Street, one thing that they were saying was that the cost was marginally higher, but I think that's because High Street being the first project to do this, we had to make a custom mix essentially to get this in the project. So because of that, the cost could have been higher than what it could be for other projects, especially since if this is specified in Vic Roads now as a potential option as is, I can see more projects trying to use it and the cost being lower as well.
Yeah.
Being a waste product that's readily available, I can see it being even potentially same, if not lower than what a normal concrete mix could be as well. So definitely interested in using this.
Any other thoughts from our University of Melbourne? I think so you've looked at 10% replacement. What's the future for the material?
So I think at this stage, 10% is still quite conservative, because I think at this stage, the concrete industry is just looking for a very low risk and kind of safety replacement for sand. But in the future, I'd say we can just, it's still very helpful, we can push the replacement up to probably 15%. Yeah.
Any, I suppose, my last words of wisdom for projects potentially adopting this mix design from Dev or the team?
Yeah, I'm happy to jump in. One thing that I guess when I was having a chat to my colleagues about this trial and trying to get an understanding of the initial ways that we came about and about doing this, one of the things that really came out was the fact that it was really that engagement that we had with Sustainability Victoria and also then University of Melbourne that really made this trial happen. So definitely engaging with the research and development teams out there through forums like Sustainability Victoria or even Ecologic, as an example, you can kind of, it helps to bridge that gap between like what's being researched out there and what you can do as well. So one of the big takeaways that they were telling for me as well was saying that it's really important to kind of continually engage with research and development to see what's out there. And there is a lot of opportunities out there at the moment. So to really investigate and explore opportunities and see if there's anything you can trial in your projects to kind of keep that innovation going forward as well. Anything that's feasible, But yeah, just something from me.
Great, thank you. Echo or Philip?
So you want to say something?
Yeah, if there's any other sort of final pearls of wisdom you want to impart.
Yeah, definitely. I'd echo what Dev said. And if there's listeners that are thinking about implementing something like this or have some specific things in mind, and definitely we're interested in engaging with that, and we'll be definitely putting forward another application in future rounds from Sustainability Victoria. And this was a great opportunity to really showcase one aspect of the research. We'll definitely be furthering that as we move forward. So definitely keen on collaboration. If anyone is interested, just definitely let us know about that.
Thanks, Philip. I do believe Sustainability Victoria have a couple of funding rounds open right now, which close on June 2nd, I think, for both
Correct.
research and development and commercialization of new recycled materials. So thank you, everyone, for sharing the journey with us. I'll invite Cheryl back in because I think we have a few questions coming in. So Cheryl, did you want to field them, or shall I? Or you're on mute.
Just realized I'm muted. Did we talk about the fact that this has become the standard and spec was updated? Okay, I missed that bit. Sorry. Yeah, the first question is asking what size of glass fines were used in the concrete.
I'm happy to just put up a particle size distribution. Is probably the best if I'll just share screen that so we can have a little bit of a look at how it compared to, say, natural sand and the limits presented in the standards. So you can see the yellow and the light blue line were our recycled glass fines here. So they're sitting, somewhere right in the middle of the standard. And somewhat to the left of the natural sand. So we had larger particle size generally from the recycled glass fines than you would find in the natural sand that we used on our baseline here, but still well within the standard limits and quite a broad distribution. We didn't only have one size there. So hopefully that gives you a pretty good indication of where the glass fines sat in terms of the size distribution.
Great. The next question, there's a couple of statements and then some comments, but Nelson's saying the glass itself has very high embedded energy from melting sand at very high temperatures to manufacture the glass in the first place. A first principle of sustainability is energy reduction, which includes not wasting the embedded energy in materials. Has anyone got any comments on that?
I would love to have a comment on that because it's definitely a focal point of a lot of the research that we're doing. And I think we have to look at in the construction industry as an industry, what can we do to help address these issues? We're not manufacturing the glass to put it in concrete. The beverage industry is doing that. And so we've been presented with a problem, and that is these not readily recyclable glass fines that cannot go back into glass bottles and that are just going to landfill. And as Dev pointed out, rightly so, we were also being less sustainable in terms of harvesting natural sand. So we can solve two problems by using these glass fines. One, we can reduce our impact on the environment by not having to use natural sand. And two, we can divert this waste from landfill and put it into concrete and into these mixes. So I agree with you, manufacturing the glass has high energy, but we're solving a problem at the latter end of the beverage industry, I guess. And definitely Dev or Echo, if you've got a few things to add to that, happy as well.
Yeah, I think I totally agree with you because these unwashed waste glass fines are actually the byproduct of recycling the glass. It's not us, we don't manufacture any new glasses. It's those glasses, if we don't use them, they have to be landfilled or go to the stockpiles. Yeah.
Which is ultimately the aim with what we're doing at Ecologic is using waste materials that otherwise would land up in landfill, and that's what we're trying to reduce. So this is a fantastic opportunity. I'm really glad that Nelson asked this question because it's one of the myths that we like to bust. But any comments on the health issues manipulating glass? I know this is a different project, but we might be able to broadly talk about it. And he's saying i.e. silicosis, but generally glass handling, recycled glass handling. Can you comment on it?
I've got a brief one, but definitely keen to hear Dev and Echo on this. So a few studies have been done on this, and I can definitely send through the links to Ecologic after this. But they've generally found that the recycled glass fines has lower respirable crystalline silica levels than traditional sand. So yes, we have got those same risks of silicosis as you would with normal sand, but it's not as high a risk. So V-Line looked into this in 2021 for mostly looking at, say, bedding materials, not substitution for glass fines in concrete. And the Australian Food and Grocery Council has also done a little bit of work in this area as well. So yes, it's a risk. but it's one that's reduced compared to traditional sand, which is, I guess, good to see.
That's interesting. Because sometimes, and I don't know if you can comment any further, but sometimes there's I guess there's a smell, or there's a perception of smell if it's unwashed, but I don't know if you can comment on that as well.
Yeah, I'm happy to just jump in a bit there. I think I guess because the application of this unwashed glass fines is a bit different to the usual way where that could be an issue. So I know usually when it's used as bedding material, when the workers really have to put it in directly exposed to it, is usually when that II issue comes around, when people are saying, no, you know, because the smell, we don't want to deal with it. And that's understandable. But in this particular application itself, it's already incorporated into concrete. So because the fact that it's not a direct exposure per se for the workers on the ground, I'm talking about like the workers that are actually going to be, you know, using the mix itself. We as in High Street, we never had that issue for this project per se, because because of that, there's no direct exposure to it. And of course, that does mean back in the concrete plant, when this is all mixed together, there could be issues. But I guess also because that's again possibly done in a more commercial setting, that could be handled as well. But yeah, just some thoughts from me. In terms of the concrete use itself, we didn't have any issues when it comes to smell.
Great. No further comment. There's one more question that's just come in. How do the particle shapes of the RFG compare with the shapes of conventional sand? And is this likely to cause any problems with the resultant concrete?
I think for the yes, I'm happy to answer that. I think for the particle shape, it's fine that the recycled glass is usually more more angular or sharper than the natural sand. But if we keep it like this as this low replacement, it won't have any big effects on the performance of the concrete. But if we do increase the replacement, probably say more than 20%, then we probably see a more obvious strength reduction due to this different shape, because it's more angular and has more like the stress concentration around the edge of the particles.
Yeah, I completely agree, Echo. I'd also say that if we were substituting as, say, an aggregate rather than a fine, so a coarser aggregate on the sand, that starts to become, or the glass fines, I should say, that becomes more critical, because then we're getting mechanical issues with, say, planes of glass. So at the finer level, it's less pronounced than at the coarser aggregate level. But again, coarse aggregate replacement for glass is not, it's not really solving anywhere near the problems of the fines for glass, because the coarse glass can typically be recycled back into glass bottles. So there's less incentive to, of course, put it into concrete.
Okay, interesting. Great. Someone's just asking for us to share the product details of the product via email. Do you have? There's a. That's what I was going to do. There's a case study that Sustainability Victoria have that I was going to put up and I haven't, but I can do that. And also, are there details, Dev or Uni of Melbourne, are there things that we could share? I don't know if I can email to everyone because of the way that you register, but we're happy for you to email us at ecologic at roadprojects.vic.gov.au, and we can send it out to anyone. But if I can work out who is on this, because we have lots of people registered that are not here, we can send out any information. Can you quickly just let us know, other than the case study, what might be available? And I'll quickly look up that case study as well.
I'm happy to reach out to Hanson, who are the main contributor to the actual mix design itself for this trial, and see if that's something that they'd be happy to provide more information on, and get in touch with you, Cheryl, see if we can distribute that information.
All right.
But I'll have to, after I get in contact with them and see if that's something they'd like to do.
Okay. All right, that's great. I don't think that's it. Yeah, I've just found the link. So I'll just put this link in the chat, and So everyone in the audience should be able to see that. I don't know if that's going to work. I don't think that's not going to work. Okay, I'll have to work that out and try and shoot that out to people as well. Looks like we might have got one more question. No, that's it. All right, we'll work out what information we can get out to people. Just like to, oh, hang on. Yeah, that's okay. Just like to say thank you to everyone for participating. Next week, we are talking once again to Daniel Cole-Morgan from Mordialloc Freeway. Oh, we've got one more, I think, that we've missed. Yeah, we've answered the question of the size of.
I think sorry, Phil, it's a quick one, but can you have an exposed aggregate finish with this product is the question. There we are.
Okay.
Last time.
Can anyone
Not
answer
sure
that?
if Philip or Echo, you've got any thoughts on that one?
I guess if you do the exposed aggregate finish, that's more like for the just for the aesthetic appearance. I think I've seen similar studies before. You can do that, but probably you need to do some extra experiments on the abrasion resistance or something like that.
I'd also say there's less, often the exposed aggregate finish is something that you're doing exactly as Echo said for aesthetics, and you'll use coarser glass particles for that so that you're getting a really nice, I guess, architectural almost finish, whereas our glass particles were not really that large to give that really impressive architectural finish. So typically on these exposed aggregates for glass, in concrete, we're just using larger pieces of glass and often, different colored glass to get that effect, which is, I guess, a bit less of what we were trying to do here.
Great. And I have popped that link in the chat if anyone wants it. I worked it out. We've got it. It should work. We've got one new message, but just a thanks. Okay. Thank you everyone for attending. Thank you very much, Philip and Echo from University of Melbourne and Dev from the Northwestern Program Alliance. It's great to have the mix of people that we're getting on here. And certainly if anyone's got any topics they'd like to talk about, please shoot us a message. And hopefully we'll see you next week, which will be our second last session. Once again, we're talking about noise walls on the Mordialloc Freeway. So that's the recycled plastic noise walls. And thank you again.
Thank you, everyone.
Thanks,
Thank
everyone.
you.